Assalamualaikum. My name is Muhammad Rosli. I will present about introduction. With global energy demand rising, fossil fuel use causes serious environment harm. Solar energy is a clean, sustainable alternative, especially in sunny region like Malaysia. Flat plate solar collector are what used to heating water due to their low cost and simple design. They absorb sunlight through the coat plate, heating water in the tube with insulation and glass cover to retain heat. This project use a theory and CFD simulation in assist fluent to study heat transfer and temperature distribution, helping assess and improve the system efficiently. The objective of this project is understand how to flat plate solar water heater works by converting solar energy into heat. It involve design the system with accurate design dimension using engineering software, performing basic heat transfer calculations such as energy balance and heat loss, and simulating the fluid flow and temperature using NC fluid. Finally, the result from the theoretical analysis and simulation will be compared to evaluate the system performance.
My name is Muhammad Adi Azmi, so I'm going to present my part, which is final design. We create a solar water heater using engineering software. The design allows water to flow smoothly from the inlet to the outlet over the absorber plate or flat plate to absorb heat efficiently. The main component include flow tube and absorber plate, insulation and transparent cover or glass arranged to support effective heat transfer. This system is simple, reliable and affordable, making it suitable for home or small-scale use. We also focus on material selection, surface area and flow direction to improve thermal performance. Next, the dimension of the system. These were carefully chosen to ensure efficient heat absorption and smooth water flow. Here are the key measurements. Flow tube length 1075 mm, inner diameter 111 mm, outer diameter 125 mm, absorber plate width 1125 mm, absorber plate length 1075 mm, for absorber plate thickness 50 mm. This dimension help the water stay in the system long enough to absorb heat efficiently while keeping flow consistent and reducing energy loss.
Good day everyone. In this simulation, we use two materials, copper and aluminium. To analyze heat transfer performance, the material properties such as density, specific heat and thermal conductivity are shown here. As you can see, copper has a much higher thermal conductivity than aluminium, which suggests it can transfer heat more efficiently. For the boundary conditions, the solar heat flux is set to 800 watt per meter square with an initial water temperature of 27 degrees Celsius and ambient temperature of 25 degrees Celsius. The inlet pipe mass flow rate is 0.05 kg per second and the heat transfer coefficient is 5 watt meter square point K. Next, this slide shows the temperature contour plot of the solar collector. The temperature increases gradually from the inlet to the outlet, reaching a maximum of around 582 Kelvin. The red areas shows the highest temperatures, indicating effective heat absorption. This result confirms that the solar collector is working efficiently to transform and retain heat from the solar input.
Assalamualaikum, my name is Muhammad Fakrul Hakim. Today we will compare the theoretical and simulation result in our heat transfer analysis. As you can see, we have two temperature scenarios, one at 40 degrees Celsius and 25 degrees Celsius. These values are critical as they allow us to calculate the heat transfer rate. First, let's look at the conduction heat transfer rate, Q conduction. Using our theoretical calculations, we find a value of 330.6 kilowatt while our simulation shows us a slightly higher value of 6,250 kilowatts. This is quite significant. We're using heat transfer rate formula, which is 2 pi times length times thermal conductivity open bracket T1 minus T2 divide lon diameter outer divide diameter inner. Next, we have the convection heat transfer rate, that is heat transfer coefficient times area times T surface minus T fluid. The theoretical value here is 562.5 kilowatt compared to simulations 1063 kilowatts. We see a notable difference. The goal of this analysis is to evaluate how well the simulations align with the theoretical assumptions. As we can see, there are discrepancies between the two methods.
Hi everyone. In this study, we explored how heat is transferred in a flat plate solar water heater. We look at both theoretical calculation and run simulation using ANSYS Fluent to see how closely they match. The result gives us a better understanding of how the system performs and where it can be improved. This kind of insight is really useful, especially if we want to design more efficient system and promote the use of clean energy. Overall, the study show how combining theory with simulation can lead to smarter and more sustainable energy solution. That's all from us. Thanks for listening.